you are actually doing microservices? Okay, good. So I'm going to look to you to actually add more flavor to my talk. I'm assuming most people are not doing microservices, which is why I'm giving this talk. This is the beginners to microservices talk, not the you're running it and I'm going to show you something really fancy and cool. Okay? Just so we're all level setting. Again, that's the link to the talk, bit.ly/microshort, if you want to bookmark it or come back to it later. I use lots of pictures though, so it's memorize, you got to record the reel in your head while you see the slides. The agenda, microservices, pros and cons. And then we don't have enough time. 30 minutes is not enough time to see it in action. So today is going to be mostly a theoretical talk, right? Well, not theoretical as in like hypothetical, but like I'm not going to actually have a code demo. And if I had an hour, I actually have a demo showing microservices and some of the stuff I'm going to talk about. So that's to bait you into giving me a longer talk, the next FOSS4G that actually has the demo. But by then you'll all be experts, so you won't need my talk. Assumptions, you understand the web. Basically, you've written a web application. Is that a good assumption for this audience? Right? And that's it. You've written a web application with back-end servers. So most audiences, when I give these to tech audiences, I assume nobody knows what I'm about to talk about. But given that this is FOSS4G and almost half of us are usually ecologists or biologists or something else, my intro to talking about microservices is through Roadkill. And this is how you end up feeling. No, just kidding. Basically, the idea I wanted to actually start using microservices because I was reading a lot about the hype, and I was like, oh, this is really interesting in Netflix and Spotify. That's really interesting. What does it feel like to use it? So I'm actually an ecologist by training, and I actually worked a bunch on environmental impact plans and habitat conservation plans. And as part of that, one of the ones I worked on was the Altamont power plan, the Altamont wind farm. You guys heard of that? If any of you are from the Bay Area or have seen it in the Bay Area, it's not the one down in Palm Springs. It's the one up north when you drive out from Oakland east. There's this huge wind farm. It's an old wind farm, and everybody had their whatever saying you want to say for being upset about the wind farm because they kept killing raptors. Right? And it was obvious that they were killing raptors because you go and there's a raptor dead on the ground. And so everybody was complaining. But then I was out there once with the Audubon person, and he was talking about, yeah, we kill way more birds through skyscrapers than we ever do at the Altamont wind farm. It's just nobody sees them. And then I was like, oh, well, now I'm driving down the highway, and I just started paying attention to actually how many dead raptors are on the side of the highway. And there's a ton. But they're non-point, right? So point source, the pipe going into the stream, everybody gets upset. Non-point source, everybody's spreading fertilizer and pesticides on their lawn, it's nobody's fault. So everybody gets upset about the Altamont because it's a point source. Roads are non-point source, and I think most people don't pay attention to it. And actually there's a ton of carnage out there on the roads if you actually pay attention. So I was going to build the ways of Roadkill, and not for culinary purposes. So I started architecting it, and that's when I started playing around with microservices. So I just wanted to give you, this is based on like building a real application that never went into production. So let's talk microservices. How many of you have heard of it? I'm assuming everybody's heard of it. And you're like, wow, that's kind of interesting. I should be doing it. Everybody's talking about it being a hot new thing. Microservices, Docker, DevOps. Why am I such a loser? You are not a loser. And I want you to feel good after this talk that you can actually start doing microservices today. All right? So Martin Fowler, has a page where he probably started most of the discussion about microservices. And so we're going to compare and contrast in an essay of 5 sentences or more, monoliths, which is probably what most of you are doing today, and microservices. And I'm going to pick on one project in GeoLand in particular, because because I love them, and that's how I show my love, is through criticism and improvement. And I would love them to see them pick up this kind of a microservices architecture. So I'm picking on GeoServer, because I'm also, yeah, exactly. Because I'm assuming almost everybody here knows about GeoServer and roughly how it works. Is that a good assumption? No? It's a big Java app that serves up maps and lots of other stuff, right? And I'm assuming most of you build apps like this now also. A monolith, right, where it does all your functions in one either big Django application. So Django's a monolith, right? Do any of you work in Django? Yeah, so Django's a monolith, right? Because everything is all together in one big source file, and it all lives or dies together. Right, and so we can pretend, or we can talk about it. Well, actually, I'm going to try this again. We're going to do GeoServer. So in GeoServer, we have all these different modules that do things that then get packaged up into one big application, and you ship it on your app server. Does that make sense? Right? So this is our WPS service. This is our WMS service. This is our WFS service. This is a WTF service. So you have all these. Okay, I'll wait for that one. Right? So there's all the W services that are actually put into one big jar file, and they're shipped, and you put them on the machine. And so what happens here is, suppose you actually write something that's very popular, and it's using the WPS service. Does everybody know what WPS stands for? Web Processing Service. So basically, geoprocessing through a server. And that's usually, WPS services are usually bound by what? I/O and CPU, right? Because they're usually performing some sort of calculation. But on the other hand, if I have like some sort of tile caching service, that's bound by I/O and just actually serving up requests as fast as possible, right? So here, if I do that in a monolith like GeoServer right now, suppose my WPS service becomes really, really popular. What's going to happen to my tile service? My caching service? Is it going to be impacted? Yes. I need to, do I need to scale up my caching service? No, it's going along fine. It basically doesn't do anything. But because my WPS service is being used so much, I actually need to scale up the entire application again on another server. Right? Because I can't scale up just the WPS without scaling up the whole app. Right? Get that problem right now with a monolith? Another problem is this server, can I pick it just for CPU? Or do I have to pick it to match every single service that's on there? I have to balance, right? So basically, what's our response? I need the biggest, baddest server I can possibly get because I don't know what's going to get used, so I need lots of dedicated of everything. When that's not actually the case for what your workload may be. So what the idea is with microservices, and it's actually a fairly simple idea, is you take each functional area of your application, and those are each separate services. They are separate, and they sit in separate application servers. They sit in that, they could be in separate languages. Shipping one big war file, you would have a war file for each service. And then some probably coordinating service on the back end, and they would each sit in their own app server. You'd probably put a message queue or something else in between, and I'll talk about that in a minute. So this is our WPS service now. Right? And we've got 1, 2, 3, 4, 5 of them running independently. So, the WPS team decides to roll out a new feature. Do I actually have to touch the caching service? No. So the typical example I use in other audiences, when it's not this one, is I use an e-commerce site. Right? And I talk about how one of the other benefits we can get is difference in sprint cadences if you're actually building an application. So if it was an e-commerce site, let's say we have a social networking service, which talks to Twitter, and it talks to WhatsApp, and it talks to Snapchat, and whatever the latest service is. And they're probably, since they're all hipster like that, they're probably using Node, right? And they're going to be probably using something like Mongo or Couch or InfluxDB or the newest, hottest thing. And they can build that entire architecture doing it that way. The people actually handling the financial part of the transaction, what do you think they're going to write their stuff in? Is it going to be Node? No. What is it probably? Java. And are they going to be backing that with InfluxDB? No. It's probably going to be in? Exactly. Or Postgres if they don't like being put over a barrel. So, but they're going to be using some sort of more stable they're going to want real transactions, right? Because transactions actually matter with money. It doesn't matter if I liked something and we lost it somewhere in the ether. But so what happens? So the social networking team, they're probably going to have an iteration maybe once or twice a week, maybe continuously. Anytime a dev wants to push it out, they want to do that. How often do you think the sprint cycle is going to be for the financial team? 6 months. The favorite answer I got to this was never, right? Because basically once that stuff works, you don't ever want to touch it again, right? It's only for bug fixes. And so what this also enables the two teams to do, it it's about autonomy, right? So the financial team doesn't really want to have a specific sprint cycle. They just want to maybe do bug fixes. The other team wants to have a very rapid cycle. So what this avoids also is the problem when everybody's on the same release for this, right? If you're doing that and you're all on the same release, how many of you have been in a situation where ship date was Thursday and you finished your fix on Friday? Yeah, exactly. And so then you had to wait 6 months until the next release. Even though if you had one more day, you could have gotten it. But maybe for your part of the project, it's okay to ship 3 days later, right? That's not the core piece. So microservices is breaking things, at its core, it's breaking things into functional, independent pieces. Okay, does that make sense to everybody? This also solves that hardware problem, right? So the caching service could be written in Node now, right? GeoServer could be JavaScript and Java. It doesn't have to be all Java. It could be Node with some sort of funky file system that's really good for serving up things really quickly rather than having to be in Postgres. Right? I mean, I love Postgres. It's my favorite database. It's the only one I basically use. But still, there might be something that's better out there just for serving up caching tiles or maybe straight off the disk. But then, for we're doing stuff like where we're supporting edits, right? Some editing service, you need transactions for that. And you need long-running transactions. So you'll probably may want to back that one by Postgres and something like Java. Right? And they can have different sprint cycles. But I'm using GeoServer as the example, but you could think about this with your own applications internally. Can you see that analogy as well? Or am I losing everybody by using GeoServer as the example? Should I leave GeoServer alone? Do you feel like I'm maltreating GeoServer? You guys can take it? You're okay with it? Is everybody? But I might be making other people feel uncomfortable. Does anybody else feel uncomfortable with that, or can I keep going with that? I'll keep using it and putting in other examples. All right. So there's going to be 3 take-homes, and you'll be tested on these at the end and throughout, because you have to reinforce. This is the biggest thing I need you to take home. The biggest. I'll let you read it. You should write it down so that it goes through the process of going from your brain through your hand and out again, but I will read it to you again. There are no requirements for languages or app servers to do microservices. I know some of you have probably seen something like you should be using Akka, you should be using React, you should be using Influx, you should be using blah, 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 blah. No. That was probably a post that came from someone who's somewhere financially connected to that language or app server. You should be using TCP. Yes, that is actually, well, no, you don't even have to. The idea, though, you could use UDP if you really wanted to. There is little talk of app servers or technology for anything. I have a friend who wrote a complete microservice application in Perl. He's a Perl web developer. He wrote it all in Perl and had a great time doing it. So whatever language you work in, I feel bad for you if it's Perl, but other than that, you can use that language now and start playing around with microservices. There is no technology required. It is an architectural pattern. Got that? So start playing with whatever take a little app, build a little app in whatever language you want. Read some articles about what's some good architecture. There's some good Slim O'Reilly books on it. You can usually get them for free at a conference or download them from somebody else's website. And just start building, start playing. That is the important part. It's not to get the technology right. It's to start getting used to that architectural pattern and what happens when you do it. Okay? There's very little talk of technology in the original microservices stuff. Then vendors glom on. Okay, so this is what my flat, fluffy architecture ended up as. I had PostGIS, or PostGIS, sitting behind all 3 of my microservices. So a lot of people say that's a bad idea. It is a bad, but it's not that it's a bad idea or a good idea. It comes with constraints, right? So now everybody's reading into the same database. So I haven't totally decoupled all my services. But that was fine for me. I didn't care. I was one developer working on it, right? But in other teams, you might not want to do that, right? That doesn't mean this isn't microservices, though. It's just a more brittle microservices, right? One of the things that characterizes the architectures is the degree of brittleness. How much, if I change one piece, do I break everything? How much, if one piece goes down, does everything go down? That's one of the reasons Spotify went to microservices, right? And that's actually why Amazon uses microservices. Because they don't want, oh, you know what? The social media piece of the app has exhausted memory, and therefore the entire app server goes down. It's like, oh, the social media part's down, but my browsing piece still works, the checkout piece still works, everything else still works. Right? So that's what you get also by decoupling, is you can have different sprint cycles, you can have pieces built to go down without the entire app going down. It can gracefully degrade. Does that make sense? Spotify uses microservices. Everybody know what Spotify is? Yeah. So Spotify uses it as well. Each of those pieces, when you load up Spotify, is coming from different microservices. Right? So then I had a data entry service and a user service, and of course, because I wanted to gamify it, there was a game service as well. Right? And none of them talk directly to each other. They all talk through IronMQ, which is a hosted messaging product. So ActiveMQ, Rabbit. How many of you have ever heard of Rabbit? For Python, most of the Python people probably have heard it. It's a message queue. And there's lots of message queues out there. I think the simplest is probably Cupid, QPID. Right? Very simple, easy to start up. The idea is it's a server that accepts and sends messages. So servers are not talking directly to each other, the services. They send a message to the queue, and then that gets sent on. And most of the good ones will actually store, you can subscribe, and when you come back online, you can get all the things you missed that you subscribed to. Right? So that's one of the ways you can decouple. Another way for doing decoupling is, how many of you have heard of the Netflix OSS projects? They have a bunch of libraries. Netflix has open sourced all their microservices stuff. They're one of the big microservices poster children. Right? They did microservices very early on. And they've open sourced a lot of their bits. So things like Hystrix and other things provide circuit breakers actually inside the code rather than putting it in a service. So actually, like, the user service might talk directly to the data entry service, but it's got a circuit breaker in there so that if the data entry service doesn't respond, the user service starts queuing up messages and then will come back later and retry. Right? So in one way or the other, you have to kind of allow things to die and come back. This is and then they were all talking directly to the web app or the mobile app, right from the service. This is a very simplistic and somewhat fragile microservice. They can be as complicated as something like this. This is where if you had the slides up on your machine, it's easier to see. But everybody knows what a DB looks like in these diagrams, right? This part. So you have like a client. They're all talking to load balancers. This one's talking into a proxy microservice, right, that actually talks to these other two, puts the stuff back together, and gives it back to the client. While this client actually goes direct to this service, you don't have to say everybody has to go in the same way. And the nice part is actually this and this get to reuse this. And they're running on different servers, right? And a different team is managing these. And one of the other things you'll see that's used frequently in microservices is caching layers. Caching is your friend. Any questions so far? I like questions, actually, and I've been blah, blah. So any questions? I have prizes for people who ask questions, because I know people are usually shy, too. I've got USB chargers, no cables with them. We'll take one out so everybody can ooh and ah. Think of your question now while you're... Yes? So the question was, do you want a hat or do you want a USB charger? Okay. This is too hard for me to actually throw too far. But the question was, what about database synchronization? There is no database synchronization, except within a service. Notice that in this diagram, each DB is separate. And the idea is, if you want to actually put something in the database, there's no sneaky backdoor. You're not talking through some memory buffer or something or else. You have to go through the service to get to its data. And that way, it's kind of like, if you think of it, how many of you have done object-oriented programming? Or at least heard about why it's a good thing, right? And one of the things that object-oriented is good about is it encapsulates, the object is black box inside. You don't get to sneaky go inside and start messing with things inside the object. And you can think of microservices as kind of object-orienting your entire architecture. Does that make sense? Yeah. So the question, well, hat or USB charger? Okay. I only got one left, so it's obviously the USB charger is the most popular. The question was, okay, great, you've got all these databases, there's still a single point of failure, right? How do you handle this? Well, so the idea is each of those, the same way that you would handle one large database and make that not a single point of failure, you would have to do that for each of the individual services. So that's the only way to do it. I mean, in each of these, the app server for this is a single point of failure if you only have one instance running. So all that HA, high availability stuff still applies. It's just you now, instead of doing it to saying it's at the whole architecture level, it's at each individual service level. Because some things you might be able to tolerate no high availability. That social networking service goes down. I'm not paying for an Oracle rack license just to do just to do that. But I will be willing to put one Oracle instance up for that. So you don't get high availability on that. But the financial transaction one, I'm paying rack on that because there's real money resting on that. Does that make sense? And now you have the independence rather than everybody having to subscribe to that service. But there's still a trade-off. And that's coming later when I give the cons. But thank you for that softball. Yeah. Yeah. So this is one of the things, I'll get to this in the con. Let me get to it. I promise. You can have a swag for it. What do you want, hat or USB stick? I'm not trying to rip you off. What? I mean, not USB stick, charger. You want the last one? All right, folks, there's 2 hats left, so decide whether you want to still ask questions now. If you're not like a hat person, it may not be worth your question. All right, that's another con. I promise I'll get to that con. Sophia? Okay, that's also in the con. So everybody's hitting the good cons. I think that's in the con. If not, do you want a hat, Sophia? What? You already got a hat? Oh. Okay. Your kids, what about your daughters? Won't they want a hat? Okay. Fine. I won't give you my hat. There's a bunch of cons coming, and that's going to be part of the second message. Can I keep going? All right. Everybody gets the architectural ideas and some of the benefits we're getting? Okay. So this is also, I've talked about the technical pieces of it. If you talk to some of the people who actually do microservices a lot, or some of the pioneers in this field, Adrian Crockford, he was at Netflix, he talks about this a lot. I'm about to give you the hardest part of microservices. So I'm assuming at most of your companies, if you are app developing companies, like where you develop apps or you have an internal IT team that's developing apps or something, you have an human resources that looks like this. You have UI specialists, they're all on Macs. Their favorite tools are some sort of nice GUI things, and they all have Photoshop, and they talk about how dumb the middleware specialists are. And then the middleware specialists, they're probably all writing Java or some other back-end code, and they talk about how arty-farty the first group is, and they all hate each other because they can't talk well with each other. And then both of these groups hates on the DBAs, because the DBAs are the ones holding things up, because they want all this process change around the database, and these guys say these guys don't understand how to keep things up. And then below this, which I wish they had put, but they didn't, are sysadmins. And everybody in the entire stack up above hates on the sysadmins, and the sysadmins just feel bad and complain about how nobody understands how bad life is for them. How much time do we have, since they're clapping over there? Okay. So how many of you have this kind of HR organization at your current company? Roughly, so, I mean, if you're more than like 10, 15 people. If 10 minutes, that's it? Holy crud. Okay, so what ends up happening is your architecture mirrors the pattern of your company, and this is called Conway's Law. That's how you have to do microservices. And this is the biggest reason why I see a lot of companies moving to microservices. And it's also the hardest part. If you have to actually have co-functional teams with everybody on the same team. That team owns that service. It's not something like, oh, the front-end people just throw the code over to the middleware people, and the middleware people just throw it over the wall to the sysadmins, and then the sysadmins are responsible for keeping it up. That entire team owns that service. So guess who gets beeped when that service goes down? That team gets beeped. It's not the ops team that gets beeped. It's that team that gets beeped. Because how many of you have been at companies when the ops teams get beeped and they're like, I have no idea what this app is doing and I have no way of debugging it. Why are you bothering me? I just do Control-Alt-Delete and see if it comes back up again. Or System D restart, right? So this is, no, you own that. So what this is really about is each team owning its own service, and I would say put a sysadmin on those teams. And this is one of the biggest yet hardest parts of microservices. So here's the cons. So again, the hardest part is political and people. So my way to get around this is start with a small little team at your company of people who want to try this out. Don't say, we're going to microservice the entire company. Start with a small team, build something, work through some of the kinks, and then show how it's done. Because you're never going to convince HR managers, oh yeah, you had a team of 5, but we're going to take them all away from you, and now you're in charge of something completely different. Right? So this is that complexity that we were starting to talk about. How do you test, deploy, manage, backup, all that stuff? Before, when it was just one big monolith, and let's say it was in Java, you just plugged into that one running JVM, and you got all your metrics right there. You can't do that anymore. You just had one big Oracle rack instance. As long as that was up, everything was up. Right? So what you've done, and I think the thing, though, that some of the people, the real big proponents of this have also talked about is in the monolith, all that same complexity is there. It's just locked up tight inside that big monolithic application. And so if things go wrong, you still have the same problems. What microservices does is kind of cracks that open and makes you actually explicitly document it and treat it. All right? And then another thing is if you have a big existing app, how to untangle that and make that into a microservice app. That's actually quite hard to do as your first project. I recommend your first project be some sort of small greenfield thing. Right? And then once you kind of understand the pattern, start taking chunks off your monolith, like the easiest piece to take off, and then leave the rest alone, and then have one other service, and then take another chunk off, and then, or just say, that sits on the Red Hat Enterprise Linux license for 10 years, and I'm never touching that app again, and it's going to run on VMs, and just the way it is, and we're just going to keep living it like that. Okay? But it's not right for all applications. So this is the second take-home message. Do not microservice all things. It's a cool buzzword, just like Docker and containers, but do not microservice all things. Okay? If you come out of here and you're like, oh, microservice is the best, oh, I'm taking the whole company to microservices, I will come find you and beat you with a noodle. All right? It is not true. So like if you're doing what is one of the things, if I go back to this diagram, why is Cisco happy about microservices? That was a big hint because Cisco sells what? What kind of equipment? Network equipment, right? So what's happening with each of these? All that jumping around. This is a very chatty app. This is very chatty. So if you're writing a financial trading application where like distance to the data center actually matters because of the speed of light, you are not using microservices, okay? It is chatty. But I would think for most people, actually, we overestimate the cost of chattiness. Okay, so don't necessarily say, oh, because devs always, I need 32 gigs of RAM and I need hyper speed. My stuff is really try it first and then see, and then put pieces together if they need to be put together. Okay, but it's not right for all applications. We probably have 5 now, is that right? 5? 6? Oh, the world. Tools to help, surprise, surprise, coming from me and the OpenShift guy, but something like Platformasaservice, right? This helps you, this does all the coordination behind the scenes for you because there's a lot of new management stuff that you have to do. You don't have to start there though. Put some of your external services in a private or public cloud, so like your message queue should actually probably be in a separate, you put that in as a service and offer that as a service. Or logging. Like, so one of the things that happens with that big application with all those pieces, suppose you have 6 different instances of your app server up, and you have 10 different instances of your database up, how do you actually look when there's an error? How do you figure out what that is? It's not just one machine talking to one machine and I'm looking at one log file. Right? So logging becomes a much bigger issue as well. And there's companies that can help with some of this stuff. And the part of the reason, and so this ties, did any of you go to the AWS talk before about running this stuff in the AWS? Right? So he said it was more expensive. Yes, it's more expensive, but it also, there's a huge win for you in terms of not having to manage that yourself. So like logging, log entries, Logly, there's a whole bunch of software as a service providers that you just use them to start with. And then once you reach a certain size, then it's like, okay, now it makes sense for me to build my own solution. But you don't always have to start with building your own solution. Now we're down to 5. See, I almost got the whole slide in 1 minute. Micro frameworks. So how many of you are Java developers? Okay, JAX-RS is the key to life. It makes me, I started using it. It's basically annotations. I felt like I was a Node developer. I started to grow a beard. I was drinking dark coffee. So JaxRS, Sinatra in the Ruby world, or any of you Ruby developers? Few? None? Yeah, it kind of came and went. Flask is Python. So I'm assuming most of the other people are probably Python developers in this room, given that I'm at a Geo show, right? So Flask is a micro framework. I know most of you probably use Django. Django is not a micro framework. It's very opinionated about the entire way your app is going to be built. Flask, at its very core, something like Bottle is, I'm just going to help you route URL requests, right? API generators. So have any of you heard of Swagger? Yeah, so Swagger, you can actually define your API, and it will generate the source code and generate the JSON that you're going to be sending back and forth. And that way, everything lives in the generator, and you can actually, as you update it, you regenerate your documentation, and you can regenerate your code. Benefits, easier maintenance, right? A bug in the caching service doesn't mean you have to take down the financial service to try to fix it, and you can fix it faster. Easier communication. So this actually forces teams to communicate, because each service actually has to define their contract between them. You're going to have to give me a request like this, and I'm going to give you JSON back like this, or XML, or something back like this. There's no more like, well, I'm just going to peer into your object and try to guess what I'm going to get, right? No, you don't get to know what I do behind the scenes. The only thing we're going to talk about is, here's my API call, and here's what I'm going to give you back. That's the only, but they actually now really have to talk about it, rather than more team autonomy, and I've talked about this a lot. I was at a large insurance company in Connecticut. I know that doesn't give much information because they're almost all in Connecticut. But he said the reason that his team was taking on microservices is because he was tired of teams bickering. This should all be in Java. It was Ops' fault. Blah, 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 blah. This is like, no. You own this, and you get to make all the decisions. We can bicker about the API and what data is going to go back and forth, but you don't get to tell me I shouldn't be using that app server. It's my team, my decision, and I live or die on it. More automation of grunt work. You can't do this all by hand. So one of the things this also forces, and I know I said the word DevOps in the beginning. DevOps is peanut butter, and microservices are jelly. They taste good by themselves. If you like peanut, I like peanut butter. Do you guys like peanut butter? Yeah, so I like peanut butter by itself. I can eat it by itself. And I really like jelly. But if you put the two together, it's magical. So DevOps actually brings a lot to microservices, because it's really hard to do all this management and configuration change and all that stuff at a large scale spread out without automating some of that, okay? And that's where DevOps comes in. And this comes from my therapist. So I'm divorced, that should give you a hint about this. And that statement was said to me by my therapist, which I have found to be invaluable in all aspects of my life. So this third take-home message you can actually apply to your own life in other areas. It is clear boundaries, infinite possibilities. And so that is what we're getting with microservices, which is, here's the boundary between us, an API and data. That is a very, very clear boundary. I can do infinitely other things behind that boundary, and it's none of your business. Leave me alone. Don't yell at me. Don't tell me what to do. We just have very clear boundaries. And yes, you can share your opinion if you want, but I don't have to do anything with it, right? So you could also see how this might apply to a marriage. So clear boundaries, infinite possibilities. This is also good for work, too. I've noticed also at work, like a lot of times when there's a lot of friction, it's because boundaries aren't clear. Like, who's responsible for this? Well, I'm responsible, but I can't do, anyway, I don't need to go into all the parts of this, but this is a great saying, but this is also what microservices is getting you. So what was the first take home? No, that's the second, but that was a good one. He got the second. The second was, don't microservice all things. What was the first? Huge, letters, big, and I told you there was going to be a quiz. No language or technology is required to start playing with this right now. Okay, so no language or servers, don't microservice all things, clear boundaries, infinite possibilities. So let's wrap it up. Microservices as benefits. They give you resilience, blah, 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 blah. Done. I have 2 hats left if I get it too good. I think we have time for like one question. Oh, because we got the break, and nobody needs coffee. I got 35. Lock the doors. I'm not trapped here with you. You're trapped here with me. All right. Any questions? Yes. So the question was, is integration testing more problematic, or is that what you said? Basically what you were saying? Yeah. So the thing is, actually, in certain ways, integration testing, no. I'm thinking, so you mean integration testing like at the entire app level? So that actually becomes easier. This is one of the things I actually liked about this. In the demo, when I drive this demo, oh, he said between services for integration testing. when I drive my demo, I've actually written a bunch of microservices, and because they're all REST endpoints, it's very, very easy now for me to exercise them. I actually use BlazeMeter. It's a as-a-service JMeter tool, and I just basically load hit it with a whole bunch of get and posts. And I know whether it's I can test that JSON, whether it's actually giving me that JSON back or not. And I, as the crappy UI designer that I am, don't have to worry about how it's going to look. The UI people can take care of that, right? So I get to actually exercise all the bits. It gives us another way of testing, which we normally might not have otherwise. If that makes sense. Does it? Some? I mean, you still have to test all those endpoints, but now you can test them using BlazeMeter or JMeter or any of those other, anything that can do a HTTP request and get or post, and then you can look at the payload and see is it right. Because you've come up with a contract for what does it look like when I send something in, and what should I get back for that. But then you have to use something like Cesium or something else. No, Selenium for the UI testing on it. Any other questions? No? There's a hat. Yes. Can I have a hat? Yes. And usually that is a disqualifying question, but I don't really want to take that hat home with me, so you win. Thanks, everybody.